So now we've gone through the three different types of problems we'll be looking at. But now I want to go through and look at the examples that are along the right-hand side. And before I go through and solve them all, I want to compare them to the images that I have for my three situations and go ahead and label them as to which one I'm using. So that way we're all prepared with which set of rules or formulas we're going to be using. So if I look at example 1, I have two secants that are meeting outside of the circle. So this is going to be using secant, which is the second one in the middle here. And then if I look at example 2, that is chord. And looking at example 3, that is secant. And example 4 is a secant tangent. So now I'm going to go through and work out each one of these individually now that I know what my plan of attack is for each one, which setup I need to do. So looking at example 1, secant, I have this whole secant. I'm going to do that in a different color, in a different direction, which has the whole being x plus 9, and then the outside is just x. So we're going to set this up as x plus 9, the whole times the outside x, and that's going to be equal to the whole. 4 plus 5 is 9 times the outside, which is just 4. So we go through distribute. We've got x squared plus 9x equals 36. I'm going to move that 36 to the other side. So we have x squared plus 9x minus 36 equals 0. And then I'm going to need to factor. So x, I'm going to have one positive and one negative. So numbers that multiply together to be a negative 36, but add together to be a positive 9. So my bigger number has to be the positive here. So we're going to go with 3 and 12. Now I set each one of these equal to 0. And we find out that x is equal to positive 3 and negative 12. Now, remember, this is getting plugged in to our problem for x. And if I plug in a negative 12, what's going to happen? Is that going to work? No. No negative lengths. So please remember that. No negative lengths. So your only actual answer is x equals 3. So x equals 3 units. That's all part of one problem. Okay, looking at number 2, we are going to pick two that are on the same chord. So I'm going to pick this chord. And so our setup for this is going to tell us the two pieces. So 5 times x is going to be equal to the two pieces on the other chord, 10 and 6. So we multiply this out. We get 5x equals 60. Divide by 5. And x becomes 12 units.